Chapter 10, Section 6. Objective, learn to use the fundamental counting principle. Essential question, how do I find the number of possible outcomes in an experiment? If there are m ways to choose a first item and n ways to choose a second item after the first item has been chosen, then there are m times n ways to choose all the items. This is the fundamental counting principle. Let's put it into action. License plates are being produced that have a single letter followed by 3 digits. All license plates are equally likely. Find the number of possible license plates. So we have a single letter. There are 26 letters in the alphabet, so that's how many choices we have, and 3 digits following. We count each digit separately. That would be 0 through 9, which is 10 total single-digit numbers. So for the letter, we have 26 choices. For the first digit, we have 10 choices. Same for the second, same for the third. To get our total number of possibilities, we multiply them all together, and there are 26,000 possible license plates for this combination. Find the probability that a license plate has the letter Q. So now we know that Q is going to be the letter, so we only have one option. But our number choices are the same. We have 10 choices for the first, 10 for the second, 10 for the third. Now why do we have this 26,000 in the bottom? Because we're being asked for the probability. So when we multiply all these together, that's our numerator, out of the denominator of 26,000, which is approximately 3.8%, or 1/26. Find the probability that a license plate does not contain a 3. So let's use the fundamental counting principle to find the number of license plates that do not contain a 3. We don't need to know specifically what number is missing, but we know that if we take 3 out of the equation, there are only 9 single digits to choose from. So we still have 26 possible letters, but now we have 9 numbers, and 9 numbers to choose from. So we get a total of 18,954 possible license plates without a 3. Yes, that would be the same if we took out any other single digit number. So the probability that there is no 3 would be this value out of the total number of outcomes if we use all letters and numbers. So we still are doing part over whole when it comes to probability. Social Security numbers contain 9 digits. All Social Security numbers are equally likely. Find the number of possible Social Security numbers. So there are 9 digits. So the digit, it's just representing the positions, 1 through 9. And each position has 10 options, 0 through 9. So 10 choices, 10 choices. So we would multiply all of those together. So there are 1 billion possible combinations of Social Security numbers. Now let's find a probability with that. Find the probability that the Social Security number contains a 7. It does not matter where the 7 is, so we always put what we want at the beginning. We're looking for probability, so it's out of our total from the last problem. So there's one way to choose a 7, and then each other position still has 10 different values to choose from. So we multiply that together, and when we simplify, it simplifies down to 1/10. Find the probability that a Social Security number does not contain a 7. All that has changed now is that we want to take the 7 out. So we can't have a 7, which means we only have 9 numbers to choose from in all positions. So we multiply that together, and we get approximately 4/10 when we divide by 1 billion. Make sure your notes are filled out completely. On the left-hand side, write questions that could be answered from the material in your notes. Review your notes and get your summary done when you're finished.